hello to my lecturer and my friends. Today we are going to discuss about statistics conic section. Before we proceed to the introduction, allow us to introduce ourselves first.
I'm Ung Chin Vân.
I'm Ung Jin Han.
I am So Casey.
And I'm Wong Race.
So now let us proceed to introduction. So what is a conic section? Conic section is a geometric shape that is obtained as the intersection of a plane and a cone. More specifically, if we take a plane and slice through a cone at various angles, you will get different types of conic sections. There are four main types of conic sections, which are circle, ellipse, hyperbola, and parabola.
These are some examples we use conic section. First, optics. Lenses and mirrors often have surfaces that are shaped like conic sections. For example, a parabolic mirror is used in telescopes and satellite dishes to focus light. Second, engineering. Conic sections are used in the design and analysis of various structures, such as bridges, arches, and dams. They are also used in the design of reflectors, antennas, and other optical systems. Third, architecture and design. Conic sections are used in architectural design, particularly for designing domes, arches, and other curved structures. Fourth, navigation and orbits. The paths of spacecraft and satellites are often described using conic sections, particularly ellipse. Conic sections are used in the celestial navigation and in calculating trajectories for space missions.
Here are some formula for the conic section, and the first one is circle. As you can see in the figure, the formula. And the second one is parabola. It has two general equations, which is y squared equal to 4px and x squared equal to 4py. So the y squared is, the graph is open to left or right, and x squared is open to up or down. And the third one is ellipse. So the difference between these two standard equations is the first one, the center of the ellipse is at the origin point, and the second one is the center is at the coordinate of HK. And the last one is general equation for hyperbola. So it has the same situation as the ellipse. So we will use this equation to solve the problem that we will present after this.
This is the question for circle. Find the center and radius of a circle with equation x squared plus y squared minus 3x plus 5y minus 8 equal to 0. Then we need to sketch the graph. So firstly, we need to expand. So x squared minus 3x plus square negative 3 over 2 minus square negative 3 over 2 plus y squared plus 5y plus square 5 over 2 minus square 5 over 2 minus 8 equal to 0. Then we need to do completing a square, which is x minus 3 over 2 square plus y plus 5 over 2 square minus 33 over 2 equal to 0. Then we need to let 33 over 2 move to the right hand side, which is x minus 3 over 2 square plus y plus 5 over 2 square equal to 33 over 2. For equation for circle, which is x minus h square plus y minus k square equal to r square. The center of the circle, center of the circle is center equal to hk. So is positive 3 over 2 and negative 5 over 2. Then for the radius, r square equal to 33 over 2. For the radius is square root 33 over 2.
Let's solve question about ellipse. Determine the equation of the ellipse with center 0, 0, length of major axis is 8 units, length of minor axis is 4 units, and the foci on the x-axis. Then sketch the graph. So we use 2 times a to find major axis. So from here we can find a. So a is 8 divided by 2, which is 4. And we use 2b to find minor axis. So from here we can also find b. So b is 4 divided by 2, which is 2. So because a is bigger than b, so our graph is horizontal. The ellipse is in horizontal. So we find a and b, so we can write the standard form of the ellipse. So this is the standard form of the ellipse. Then we just substitute a square and b square inside. So a square is 16 because it's 4 square, and y square over b square. b square is 4 equals to 1. So this is the equation of ellipse. So now we find foci. So we find foci using h and k plus minus c. Because this question, the center is 0, 0. So we can write it as 0 plus minus c. So how do we find c? We can use c square equals to a square minus b square. So it's 16 minus 4, 12. C is cert 12. So the foci is 0, cert 12, and 0, negative cert 12. And now we will find the lattice rectum. We use 2b square over a to find lattice rectum. So 2, our b square is 4, divided by a is 4. So lattice rectum is 2. So now we need to sketch the ellipse. So the vertices negative 4, 0, and 4, 0. So this is the center. This is 0, 2, and here is 0, negative 2. And the foci 0, negative cert 12, and 0, cert 12. So that's all for me. Thank you.
Hello, I'm going to share about the parabola in conic section. Okay, so basically we have 4 general equations for parabola, as you can see here. And we will use one of these to solve the problem. Okay, so here is the problem statement. Given that coordinate of bar foci is 3, 3, and the distance between bar and the vertex is 2, find the equation of parabola. And then we can briefly draw a graph like this. Here is the foci, 3, 3, and here is the distance between the vertex and foci, which is 2. And we choose this formula because the graph is open to right, and so we use the y square at the left-hand side. So we know the foci is 3, 3. We just compare it with h plus p and k. And then we will get h equal to 1 and k equal to 3. After knowing the values of h and k, we also know the coordinate for vertex, which is 1, 3. And the next one is directrix. And then we will get x equal to negative 1. For the last one, equation of parabola, we just sub inside the values of h, k, and p. So you will get 1 minus 3 squared equals to 8 times x minus 1. And here's the graph, final graph for the solution. Here is the equation of parabola, and here is the directrix. And V is vertex, F is foci, and this one, 8, is the length of lattice rectum, which equals to 4p. So P is 2, 4p is 8. And here is the distance, that is 2. So here is P equal to 2. Okay, that's all for the solution for these questions. Thank you.
Hello everyone, here's Susan. Today I'd like to present about hyperbola. So let us move on to our problem statement for hyperbola section. Question 1. The given direction closely vertex, length of transverse axis, length of conjugate axis, and extents of 9y squared minus 25x squared equals to 225, as well as another question sketch the hyperbola. So firstly, since the equation starts with y squared, hence we will use second equation, which is y squared divided by b squared minus x squared divided by a squared equals to 1. In order to get 1 as a whole number, we need to first divide the equation with 225. Hence, we get the value of y squared divided by 25 minus x squared divided by 9 equals to 1. B squared value will be 25 and a squared value will be 9. So to conclude, B will be 5 while A will be 3. Because B value is greater than A, the direction of the graph will be upwards and downwards. For the center of the graph, since there is no HK mentioned, so we'll use 0, 0. In order to find for C, we need to find C first. So C squared equals A squared plus B squared, while C equals to square root of A plus B, which is square root of 9 plus 25, equals to square root of 34. So for C, the value is 0, square root of 34, while another is 0, negative square root of 34. In order to find vertex, we need to substitute the value of B into it. Hence, the vertex value will be 0, 5 and 0, negative 5. For asymptotes equation, y is equal to plus minus b per ax. Thus, we need to substitute the value of b and a into it. The final answer will be y equals to 5 per 3x and y equals to negative 5 per 3x. In order to find length of transverse axis, we need to know that the graph is upwards and downwards. Hence, the equation used will be used formula 2b. Hence, 2b equals to 2 times 5 equals 10 units, while length of conjugate axis will be 2a, which is 2 times 3 and equals to 6 units. For question B, we need to sketch the graph. Thus, here is the final answer for the graph sketch. Thank you for watching.
In conclusion, conic sections are fundamental geometric shapes that arise from the intersection of a plane and a cone. They encompass 4 main types: circle, ellipse, parabolas, and hyperbola. The significance of conic sections span a multitude of disciplines. Their versatility and practical relevance makes them a cornerstone of mathematics and a powerful tools for understanding and solving a wide range of real-world problems. So lastly, this is the reference for our video about whether the sentence and the image that we posted inside the videos. Thanks for watching.